Hi, my name is Greg Levine, and for the past 4.5 years, I've been a senior specialist solution architect for AWS with a primary focus to assist customers with Amazon end-user computing services. I'm pleased to be joined by Max Stringer, who is the Desktop On-Demand service owner with Pfizer. Thank you, and we're excited that you joined us today as we discuss the advantages and benefits organizations can achieve for themselves when applying some of these automation methods to support their own Amazon end-user computing services environments. During these 30 minutes, we hope to leave you with three things. An understanding of the value proposition automation can bring to your environment. Briefly provide examples of automation used throughout the systems management lifecycle to show what's possible and actually being leveraged by customers today. And to learn how Pfizer has applied these principles and examples to achieve operational excellence within their environment. The well-architected framework provides design principles across these 5 pillars. By using this framework, you will learn architectural best practices for designing and operating reliable, secure, efficient, and cost-effective systems in the cloud. I'm not going to get into great depth on each of these as we don't have enough time for that, but display them here as a reminder and a point of reference to consider as we proceed today. At a high level, with the well-architected framework as a backdrop, administrators and users alike throughout automation can increase speed and agility and ultimately speed to market for your customers and users, assure desired changes and processes are repeatable, consistent, and reliable, optimize costs, so you're truly only paying for what you actually use, reduce support and management costs, empower and enable your end users on their own terms. Please note the Amazon Workspaces and AppStream 2.0 icons. As we get into these examples and automation principles during the next few slides, their presence in the top right corner indicates which services the slide correlates to. We'll start off the automation with the automation to assist in the creation of images. For both Amazon Workspaces and Amazon AppStream 2.0, these 3 options are frequently and effectively used by customers. Leveraging the AWS CLI and/or the AWS tools for PowerShell to automate image creation processes within the operating system. I'm going to quickly walk through an example of this in a moment. Using the AWS CloudFormation plus the CLI and tools for PowerShell in concert with solutions like Terraform. And finally and lastly, a reminder to not forget about any existing tools that you may already leverage and have built similar processes around and are using effectively today. I'm referring to tools such as SCCM, MDT, BigFix, Chocolatey, and there are others. These types of services can continue to be easily leveraged within the AWS EUC services. You'll want to ensure that any licensing considerations for such tools are in place, of course. Here's an example of a Workspaces image creation solution that we've built, cultivated, and I've leveraged the past several years for previous reInvent conferences as well as our North American summits. It's what I would call a light touch image creation process that is PowerShell Active Directory group policy based by design. We're going to review the components and processes briefly over the next few slides. For time consideration's sake, this is going to be a very quick tour. At a high level, you can see a breakdown of the components listed along with an example screenshot of the image creation process in action. This process was used for Workspaces, but could also easily be tailored for use with AppStream. Diving deeper, here's a breakdown of the folder and file structure, which includes FSX for Windows-based file share that hosts the deployment code repository. Within that share, a folder structure that contains the core.cmd, PowerShell, and manifest.csv files, along with a nested subfolder for each application or process, such as patching and process cleanup. I've also provided examples of the nested app folders for both the PuTTY and Google Chrome Enterprise applications. Each folder has an install.bat that calls an associated PowerShell script that automatically downloads the app installer bits from the internet and then processes the installation of the application. For each image type, I simply create an individual manifest.csv file that is named to an associated domain role ID service account name. You see an example of such a file here. When this process executes, the role ID runs a login script that ultimately calls the master image create.ps1 script. The image create.ps1 dynamically determines which manifest file to read and loop through based on a comparison to the currently logged in role ID name. Once the appropriate manifest.csv file is determined, the process opens and reads the CSV and then loops through all of the application subfolders listed to install an application or run a given process, patching, cleanup, etc. Ultimately, this image creation process has 4 light touch points. First, the initial workspace provisioning for the domain role ID using the AWS console or the API CLI. Upon provisioning, the initial login to that workspace with the role ID domain credentials, which kicks off the process via a login script. Upon the completion of the image create.ps1, the script presents a final reboot that this PC this script presents a final reboot that's this PC and then the create image window. Click OK reboots the workspace. Using the AWS workspace console to then create that image. Using this process allows me to create a fully patched image that contains the latest and most secure application versions with little effort in a repeatable and consistent manner each and every time I need to for a given event. Here are 2 additional image creation options that I wanted to highlight as they recently have been posted as blogs specific to Amazon AppStream 2.0. A slightly different take on using the AWS CLI and the AWS tools for PowerShell. And another one based on using the AWS Systems Manager, specifically the run command feature. You can see the URLs provided for more specifics on each of those options. Using the images we created with that light touch image creation process, we'll move on to automating workspaces provisioning. This example is one we also use for our various reInvent and Summits environments. This main script, built using the AWS tools for PowerShell, mass provisions workspaces by reading an associated .csv file. I'll display in the next slide. You can see this is a simple PowerShell script that simply reads each line listed in the wsinput.csv file and provisions a workspace for each user listed, and finally proceeds through the file until the last line so that all workspaces are provisioned. The associated CSV files are shown here. First, we use the user input.csv and an associated PowerShell script that reads the file and creates user accounts in the specific OU within Active Directory. There are numerous examples of such scripts that can be found on the internet and that can be used to do this. The second file, the wsinput.csv, is what feeds the provisioning PowerShell script we just discussed and displayed. Again, for each user account listed, it provisions a workspace using the bundle ID X in region Y under directory service ID Z, and then continues to loop through to the end of the list. Note that both of these are provisioning users and workspaces using a username prefix. In this case, AWS-cert-R- followed by a number 8. These were kiosk workspaces and users, so we simply loop through the process to dynamically create the AWS-cert-R-1 through AWS-cert-R-8 users. We could have just as easily created entries that contains actual real usernames like Sam Jones, Patty Smith, or whatever domain account ID format is used. One item of note is API limits. API throttles requests for each AWS account on a per region basis. We do this to help the performance of the service and to ensure fair usage for all AWS customers. Throttling ensures that the calls to the API do not exceed the maximum allowed API request limits. You'll want to take API limits into consideration as you mass provision workspaces, as you simply can't provision hundreds or thousands of workspaces at one time. To provision a single workspace requires multiple API calls, which is where these limits come into play. To manage this in PowerShell, I generally add a loop check for a given number of workspaces that pauses for a specified time window. In a hypothetical example, I could configure my loop to provision 30 workspaces at a time and then pause execution for 20 minutes in order for these non-encrypted workspaces to complete the provisioning process. After 20 minutes, the loop proceeds to provision the next 30 workspaces and so on and so forth until all of the workspaces are provisioned. My loop count check is simply a division problem where if the result isn't found to be a whole number, it will continue uninterrupted to provision a workspace for the next user listed until the next whole number result is found. In my example, it will pause for 20 minutes at a count of 30, 60, 90, and so on. I should also point out that there are more dynamic and elegant solutions and options for this API checking that are available. Just search the AWS blog. Let's shift now to day-to-day management operations quickly. Thinking of the well-architected reliability pillar, we can proactively monitor an associated automated remediation process in the event an error is found. For example, with workspaces, use AWS CloudWatch to monitor for individual workspaces that go into an unhealthy state for X number of cycles over a Y-defined time window. Once this error state occurs, then use the AWS CloudWatch to kick off an AWS Lambda function that reboots the identified workspace in an effort to proactively resolve the unhealthy state. Switching gears, service utilization is a key consideration in managing costs. For AppStream 2.0, a reminder to leverage the built-in usage reporting feature to monitor actual fleet instance consumption, analyzing this information on a regular basis to help you optimize your scaling policies over time, resulting in a more cost-optimized environment. For workspaces, I've heard and found myself that some customers are not monitoring their workspace utilization on a regular basis. When they do, they are finding numerous workspaces that are either in the wrong running mode, always on versus the auto stop, or not being used altogether. A reminder to use the Workspaces Cost Optimizer solution to assist with determining the most cost-optimized running mode on a per workspaces basis. Additionally, use the last known connection timestamp workspaces value in concert with the AWS CLI or PowerShell to help identify when the last time a given workspace was actually connected to, and meaning that it was actually used. For those of you managing EUC environments across multiple regions and thus possibly having to push updated images and then updating an associated workspace bundle or AppStream fleet, automate those tasks and save yourself time, again using the AWS CLI or AWS tools for PowerShell. Finally, from a support service desk perspective, I want to highlight the recently released EUC Support Dashboard project. It is provided for example purposes, so it is intended to be a customizable template that you can tune, tweak, and enhance to best suit your needs and empower your support staff through a single pane of glass view. As users continue to build reliance on self-service and self-consumption type of solutions throughout the various aspects of everyday life, I want to bring an awareness to existing built-in functionality and provide a few example solutions that can be used to empower your own users in this manner. These capabilities offer organizations the opportunities to reduce service desk tickets and improve employee productivity and satisfaction while being able to do so 24/7 by 365 on their own terms and timeframes. Let's review the Amazon Workspaces self-service capability as displayed here. First, the Workspaces admin is going to simply enable the self-service features they wish to from the directory services configuration via the AWS Workspaces console. Doing so allows the end users found within that directory service to then see and access those enabled options from the settings menu of the Workspaces client. I have two additional options that I wanted to highlight and pass along. The first is a detailed blog post that discusses the building of an Amazon Workspaces self-service portal that end users can use to properly assist themselves by self-enablement. The second option is one that discusses how you can extend IT service management solutions by using available APIs, the AWS CLI, or as in this specific example, using the AWS Service Catalog connector for ServiceNow. I've included those URLs here for reference purposes. Finally, another quick reminder to not forget that you can continue to leverage any existing self-service capabilities or solutions that you may already have within your environment. Solutions like SCCM in this case. Again, this assumes that the appropriate licensing parameters are already accounted for. I'm now pleased to turn things over to Max Stringer, who will share the approach Pfizer is taking to implement and benefit with their EUC automation efforts. Good day, Max.
Hi, my name is Max Stringer, and I'm the service owner for Desktop On Demand, which is the internal Pfizer branding for our Desktop as a Service offering. As one of the largest pharmaceutical companies in the world, we have a varied and globally distributed workforce comprising both colleagues and contingent workers. We've provided a desktop as a service for over a decade now, and over that time that service has evolved from an on-premises service with no automation to a highly automated service based on Amazon Workspaces. Our customer has grown by a factor of around about 10, and we now provide desktop as a service to an ever-increasing range of use cases. Our primary use case, though, still remains the contingent worker. Typically, this is a worker based offshore and using a vendor-supplied device. And our desktop as a service allows us to offer an agile and client device agnostic access to our standard Pfizer end user experience, which is Windows 10. Pfizer no longer has to be concerned with the logistics of managing physical assets across multiple countries or vendor sites, and has been able to considerably reduce the provision of dedicated connectivity. An interesting divergence from this primary use case is the role which Workspaces plays in our robotic process automation environment. We actually maintain a dedicated account for this, in which we host a significant number of workspaces that provide end-user compute purely to virtual workers. Due to our consistent user experience, Workspaces is ideal for this role. The additional agility and controls afforded as a consequence of them being virtual was significant value adds also in this role. I think a central tenet of our Pfizer desktop as a service offering is that the user experience must be consistent with that of a physical end user compute device. And this consistency allows us to consolidate our support offering. And it also means it's very easy for a customer to move between a virtual device and a physical device and back again without a jarring kind of culture shock experience as they do so. So let's just look at quickly why Pfizer chose to automate and why we continue to evolve the automations that we use here. So I think like any large multinational, we've got an existent set of services and processes and systems with which we need to integrate. We want our desktop as a service to really just be another compute device. We want to avoid a large amount of specificity, and we definitely don't want parallel solutions that really only differ in that targeted end user device. So as an example, we use SCCM for software deployment. Our customers can access an internal storefront where they can browse and download applications. This allows us to use a lightweight image for our customers, but then allow the customers the power to maintain and manage their own application portfolio. Now, we knew from the start we'd need to have this exact same experience across the desktop as a service fleet, because that maintains this ethos of consistency and allows us to use these common support processes. So a huge win also for this automation is the agility it provides us. And I think a good story here would be to relate how we responded to a need to build 2,500 workspaces very quickly, ideally within a week, and if better, if possible, within days. So we made a strategic decision to consolidate our workspaces usage back to the US East 1 region. And this was primarily around considerations of where the data, services and solutions that our customers consume are based. And it made sense for that to be US East 1. So the challenge, though, was that we had 2,500 customer workspaces in other regions. We had to build them new ones in US East 1. And in order to do that quickly and have our customers adopt those new workspaces equally rapidly, the only way really to do it was to use automation. So we were able to use our existing lifecycle automation in combination with a workload distribution technology, which I'll talk about later, to build out those 2,500 instances in only 3 days. There was no impact to our business as usual environment, which is great, and it only needed a single resource to actually launch that effort and then monitor that workload. I think we should also be mindful of how Pfizer looks at automation and the role of the overall support cost reduction. So we automate almost every aspect of the life cycle of a workspace. So if we look at just 2 key areas, the creation and deletion of a workspace, these typically would be manual processes. You know, a customer would create a ticket, it would get escalated, a group would handle it, they would then release that workspace to the customer. And there's nothing necessarily inherently wrong with that. It's not a model that scales particularly well. I wouldn't have wanted to do that for the 2,500 workspaces we needed to create. So in Pfizer, essentially, creation of a workspace is automated, as indeed is termination, and we'll talk about that a bit later. But launching a new workspace in our environment is as simple as a visit to our self-service portal or a click on a single option at the point when a hiring manager onboards a new resource. So I think if we move into now the subject around what are our automations and the things that we've done. So let's talk about the obvious thing here, which is how we create workspaces. And we provide, as I previously mentioned, 2 ways for our customers to create a new workspace. They can use a self-service portal, or they can take advantage of the integration we have with our existing IT onboarding. And I think that's a really good example of where we chose to automate because it allowed us to integrate with existing systems and processes. We have an existing IT onboarding process. It already has a check on it, which allows the hiring manager to select a physical device. It made sense to provide a new check, which says provide a virtual device. And now what we have is a solution where a hiring manager can bring a new resource into the Pfizer environment, have them create a new identity for that individual and a new workspace, and have them productive within about 3 hours, which is a pretty impressive timeline. Should just point out some extra detail on what workspace creation looks like within Pfizer, because there are some differences. It's not the same or as easy as pressing the Launch Workspaces button in the console. Firstly, we are a bring your own license customer, so we use our own image to build workspaces from. And after the basic thing of launching the workspace in the Amazon environment, there's a considerable amount of workflow that's then executed against that thing to turn it into a Pfizer workspace. And at the culmination of that process, what we have is a Pfizer flavored workspace, which is ready to be handed over to a customer. And that process, the handover to customer, is what we call the release to customer automation. And it sounds really simple. I've created a workspace. I now need to give it to the customer. How am I going to do that? Well, it's not that simple, because bear in mind that our primary use case is for contingent workers. They're only Pfizer end user compute devices, the workspace we've just built for them, and that's the only way they can get access to Pfizer email. So release automation for us is actually relatively complicated, because we have to hand over to the customer at this point a fairly rich amount of information. Simple stuff like, here's your registration code, here's where to go to register for this service and that service, and here's where to go to download the client, and etc., etc. And the way we solve for that is our automation actually publishes all of that information as a personalized web page, and we leverage Amazon's S3 static web page hosting as a way of doing that. And that then allows us to further use simple notification services as a text message transport mechanism to communicate to our users the URL to this rich information, which then allows the customer to access their new workspace. So using this sort of combination of email, text, and static web publishing, we're able to ensure that we've got a very good success rate at giving our customers access to their workspace quickly, and without that entire process incurring additional potential support cost. So if I move on from then and we talk about restarts, and I included restarts here because, as everybody in IT knows, a restart solves everything, and we have to do lots of restarts. And the way in which we choose to do this is we have a hybrid model for this automation. As Greg will have shown in a previous slide, it is possible for you to enable restarts from the self-service menu. So in other words, the Amazon client can have a setting made which allows you to go to that client and say, I want to restart my machine. And that's great. And what we actually do is we surface that to our customers, we let them do that, and then we add an enhancement, if you will, a Pfizer enhancement to that experience, because when that restart occurs and the machine comes back, we then send an email to the customer, personalized email saying, hi, Max, your workspace has just been restarted and is now available for use. So there, what we've done is we've essentially, as I say, we've got a hybrid approach. We've joined native Amazon functionality with a little bit of Pfizer flavoring to create a better user experience. I'm now going to talk about terminations, or as we call it within Pfizer, the scavenge process. And essentially for us, the scavenge process is really, really important. It's a central aspect of our fleet optimization process. So what the scavenge does is very, very simple. At the end of each calendar month, it looks at every single machine we have in our fleet, and it asks of that machine a very simple question. Have you been used in the last month or not? And if the machine says, yeah, I've been used, then the process just moves on and goes to the next machine. But if the machine says, no, I've not been used, we throw the machine away. We literally just terminate it. Okay, so that sounds pretty harsh, pretty brutal, but obviously we're very clear with our communication to our customers that we have this pretty harsh use it or lose it policy, if you will. The advantage of doing this is that essentially what this automation does is it always keeps the fleet at the right size. it also means that we attract a significant annual cost avoidance by not spinning machines for long periods of time that are not being used by our customers. And this is particularly of relevance in Pfizer, where I should add that our machines are always on rather than set to auto stop. I just wanted to also talk quickly about rebuild, because many of you will have seen that that's an option available at a self-service level within the directory again. So at the Amazon client level, you click the rebuild. We actually don't enable that, and that's not a reflection on the capability of the rebuild functionality as implemented by Amazon, but much more about the subsequent post integration with all of the various Pfizer services that we need. So as a result, we actually have a custom self-service rebuild function. We have an internal self-service portal which customers can go to, and from that they can request a rebuild, and they can also request a relocate, which is where they can essentially literally relocate their workspace from US East 1 to an alternate region that we are now gradually bringing online. So I think at this point I say that it's a good area to cover that some automation capabilities can be really simple. They are as simple as going into the Amazon Workspaces console, going to the directory and placing a check in the allow self-service restart. Some of them are slightly more complicated than that. And then there are others where for whatever reason, you may have to go down an entirely custom model. And I think a good example of that latter, where you need to go down, where we, as in Pfizer, will need to go down a custom model, is we will not be surfacing the options, for example, for self-service, disk space upgrades or compute upgrades, because within Pfizer, that requires some additional stuff to happen, approvals, etc., etc. So that would end up being a custom workflow. So I think I kind of wanted to close out this slide by saying that knowing what to automate and how to automate something, in other words, do you pick a simple hybrid or custom model, is key. And it's also going to differ from implementation to implementation. Our experience, having said all of that, would suggest that pretty much any company that's looking at workspaces, the first two things that you want to be looking at automating are definitely workspace creation and restarts. Those are the two things which, in our experience, have been the most value for money, if you will. They've given us the highest ticket count reduction and an upswing in customer satisfaction. So just as we get to the last slide here, I'm just going to talk about some key enablers that we have within Pfizer that have really been very, very central to the automations that we've done within the Amazon environment. So the first thing is a component which we rather unpleasantly call VOQ dispatch, and it's a very simple component in theory. And what it is it's how we dispatch workload into our environment. It allows us to stage very large-scale operations into our environment and do so in a way which doesn't impact business as usual. It works on the basis of understanding that workload can be measured in terms of concurrency. So VOQ dispatch knows that we can have, for example, 200 active maintenance activities at any one time. And then as a maintenance activity completes on a machine, that releases a slot, and VOQ then dispatch can then fill in that slot. And the advantage of this approach is that you essentially can always be using the environment to its maximum capacity, but in doing so, know that you're not impacting as business as usual. Now, as a result of using this over the last year and a half, I would say, for everything, what we've seen is that we are able now to throw very large workloads at the environment and be very confident that they'll run and run to completion and do so without any impact to business as usual, and without impacting the performance of the overall environment. I think the other thing we should talk about here is location services. So this is an interesting one. I think anyone who's worked with workspaces, especially when that environment has been across multiple accounts or multiple regions, or you've got users who've got multiple workspaces in multiple directories, will know that there are some challenges with finding a workspace. If you ever try to find a workspace by host name, you'll also know that that actually is not possible natively. It's a difficult one to do. So what we did within Pfizer is we've actually essentially created if you like, a name server for workspaces. So we have a giant repository, for want of a better description, of all of our workspaces, and we then provide a web API that allows that repository to be queried using obvious search terms like find me all the workspaces that belong to this user, or all the workspaces that are called this name, or all the workspaces that are in this directory. And that gives us a very, very powerful mechanism for locating any workspace anywhere, which we need for some of our lifecycle management things, and we'll see an example of that in a moment. And we also need during the build process so that we can manage that process. We have a task that runs on all of our workspaces. This is called the chimp task, and it's a very simple task. It runs when the machine starts up, and all it does is it sends a message to a simple queue services queue saying, "Hi, I'm here," and that's it. But that simple act of being notified when the machine has become available means that we're able to send that email that I spoke about earlier to customers when their machine's available after a restart. It also means that we can trigger the sort of fine-grained elements of our build process or our maintenance process. Very, very simple task, but with a lot of power behind it. I think the last thing I should say is that what we've also found is that because we've needed to be able to integrate with other services or potentially provide access to our functionality to other services, good example being the ITOD one, what we've done to solve for that is we've typically created brokers that do that, and the brokers allow us to provide our customers, our internal customers as it were, access to potentially AWS level facilities without actually needing any AWS API experience or direct access to it. So I'd use a good example here. For example, we have a tag broker, and the tag broker manages all read-write access to Amazon Workspace's tags for us. And our customers can use that broker. And what the broker does is it ensures that we stay within tag API invocation rate limits, but it also provides a data typing and validation layer, which is not there natively. This means that people that need to read and write to tags can do so using a very simple broker that we're providing, and we are ourselves then able to take advantage of the fact that the broker will manage how those tags are written, and again will respect things like the invocation rate. So the summary here then is that VOQ dispatch lets us get work done at scale. Location services and the chimp task are fundamental to every lifecycle automation that we have, and the brokers make us easy for other services and systems to work with. So I'd like to hand back now to Greg for a session recap.
To recap today's session, our goal is that this session gives you some ideas as to what's possible and provides examples you can use to assist or enhance the automation of your Amazon end-user computing service environments. As Max shared, Pfizer has successfully incorporated a number of the examples and more to assist with the management of their environment, as well as the reasons why this is time well spent. For those of you who are just starting on your AWS EUC service journey, I encourage you to start with the Getting Started guides for both AppStream 2.0 and Amazon Workspaces, as there are free tier options you can use to simply try either or both services out. Finally, there are a number of great automation and related examples of unique solutions in the AWS end-user computing blog channel. I encourage you to review and check the link with the link on a regular basis, as new ideas and solutions are frequently added. Finally, my colleagues are hosting a couple of more in-depth reInvent sessions. Krasad is discussing the scaling and optimizing of workspaces in session EUC 303, and Navi McGee is doing the same regarding AppStream 2.0 in session EUC 304. I'd like to thank Max Stringer again for sharing the Pfizer story, and finally, a healthy thank you for tuning in to our talk today. Stay safe and have a great 2020 reInvent. One last ask, if you please. We always are interested in your valuable feedback, so we ask that you please take a moment to let us know what you liked, what you may have liked more information on, and what we could have done better in today's session.